All right, we're going to talk about reactions and equations in the next few lectures. That's what our unit is all about, is all those chemical reactions. Hopefully y'all had fun on Halloween Day, and make sure you thank Miss McClendon for coming up with all the great things that we did. And you should have seen a lot of these different indicators that a reaction occurred as we were going on. I'd say the exploding pumpkin would be the energy change in temperature. I'm sure we had an energy change there.
And the gas.
And the gas.
Inside the pumpkin is the buildup of the gas is what made it explode.
Exploding pumpkin is what we were talking about now. We saw some light with a strange drink, all that green fire, and with the flaming pumpkin.
Yes.
And of course, Miss McClendon's favorite. What would we call that? The last one. The color change. Magic solutions.
Yeah, something, yeah.
The magic solutions all at the end, where she said, wait for it, wait for it. They changed from the clear to orange to blackish color. That's a color change. That lets us know. Next year we're going to add in something that gives odor, but I assure you that some of the labs that we're doing in this unit will definitely smell. And if you did the names and formulas lab, the ionic compound one, you kept seeing precipitates that were formed there. Anything else? Yeah. Okay. And these are 5 types of reactions that we're going to be dealing with, and you'll have to be able to classify them, recognize them, and predict their products when we're done with it all. So, let's get started.
All right, synthesis reactions. This is where you're making one thing. There is one product. So in the example up here, you have A plus B yields AB. There's always one product. In the example, they have calcium oxide plus water gives you calcium hydroxide. One product. Always one product.
And from the picture, you've got the skinny bird plus the worm makes a fat bird.
The next one's probably everybody's favorite, combustion. Oxygen combines with a substance and it releases energy in the form of heat and light. So if you notice in all 3 of the examples below, one of your reactants is oxygen. So you're combining oxygen with a substance to give off heat and energy.
And typically you also get carbon dioxide and water as your standard products, because most combustion reactions are with organic compounds, which we didn't really talk about. That's any carbon-based compound.
And we have decomposition, which is the opposite of synthesis. If you look at the top, you have one reactant, and it's breaking apart into 2 or more things. So in your example, all right, down here, you have ammonium nitrate, nitrate, and it's breaking apart into dinitrogen monoxide and water. Or you have your egg is hatching, and you get your egg and your turtle in the end. Sorry, I found the pictures and just had to include them. Alright, single replacement reactions. You have one atom replacing another one. So in the example, we have A plus BX, and that A is going to replace B, so you're going to get AX plus B. In our example down here, we have copper plus silver nitrate. And you're going to yield silver plus copper nitrate. So you have to use the activity series, which is on your right, and you have to look at the list. Copper is way down there on the bottom. And let's see, silver is below it. So silver's below copper. So copper's better, more reactive than silver. So copper is going to replace the silver. So you can think of, maybe you're dating somebody and he's not that great and somebody else is better comes along. You're going to dump him for somebody else. So you look at the list, something above and something else can replace it.
And it's the same thing with the on the nonmetals. When you're looking to replace metals, nonmetals replace nonmetals. It's very important to know.
Confuse them.
You're not going to have 2 metals going together. With your nonmetals, if you look at your periodic table, iodine is kind of at the bottom of the halogen rows, and fluorine, the floozy, is at the top. Everyone wants to bond with fluorine. You have your little couple dancing over here. You had the one guy, he must have been better because he came around. Oops.
He has colored shirt on.
His colored shirt made him more attractive, so this little lady said, never mind, I'm going to dance with him and dumped whoever she came to the party with.
Alright, there are 4 examples at the bottom. Let's look at those first. First you have silver and copper nitrate. So we're looking at silver and copper. So we look at silver's ability to replace copper. Silver is below copper, so it cannot replace it. So we have no reaction. In the next one we have iron and copper sulfate again. So we have iron's up here in the middle of the list. Copper's down at the bottom. So iron is above copper. So iron will replace the copper.
And we get our iron sulfate. And copper has been kicked to the curb. It does not matter if you wrote copper plus iron sulfate. The order in which you write the products does not matter. Just write the products correctly, balanced correctly, as we just got through doing in this last unit.
All right, the next one, we have some nonmetals. Bromine is a nonmetal, so we look at a nonmetal list. And then we have magnesium chloride. So we're looking for chlorine and bromine. Bromine is below chlorine. So it will not replace chlorine. So no reaction is going to occur. And finally, we have magnesium and aluminum chloride. So we look for magnesium and chlorine. Aluminum, just kidding.
She's trying to get rid of us chlorine.
Magnesium and aluminum. Magnesium is above aluminum, so it will replace the aluminum.
So I'm going to do a quick remember. We are getting products. Magnesium's going to go over here. We got to write our formulas correctly. Magnesium has a 2 charge based on its location on the periodic table. Chlorine is a 1 minus, so you get MgCl2. And aluminum by itself. We'll talk about balancing in the next podcast. Worry about writing the formulas correctly first.
Alright, this is our last kind, double replacement reactions. So double replacement. 2 things are being replaced. 2 things are switching partners. It says all double replacement reactions produce either a solid or product precipitate, gas, or water. We're going to use our solubility rules can be used to predict whether a reaction will occur.
And we'll talk about the solubility rules when we do the net ionics, so don't worry about what that means yet.
Make sure you're pairing up cations and anions. You can't put 2 cations together or 2 anions together. The cation and anion have to be together.
The way I usually have taught is like inside outside. So if you look up at the top, you see that the B with the X and the outside, which is A and Y, went together. So that kind of helps you remember that things that are close to each other will end up together, and things are further apart end up together. With your positives always written before the negatives. So we want to know what our products are going to be. So inside, outside, we have hydrogen and nitrate are near each other, and aluminum and sulfate. So you start talking, I'll do the writing.
Okay, so then we're going to get, doesn't matter, aluminum. And we have to remember the charges. You have to write the formulas correctly. Aluminum's a +3. Sulfate, look on your polyatomic iron sheet, it's -2. So we get Al2SO4, don't forget the parentheses, 3. And then our other product will be the hydrogen and the nitrate. Hydrogen, we remember, is +1. Nitrate, look on our thing, -1. HNO3.
Which, of course, is nitric acid. Now, remember that one, right? And your equations do fall into different categories possibly sometimes. On to balancing equations.